Welcome to lecture series on advanced linear algebra. In my last lecture, I have introduced the concept of basis, dimension and also order basis. That is, basis within order, a finite sequence of vectors which also span the vector space itself. That is basically order basis. By introducing order basis in a finite dimensional vector space, we have seen if we consider V is a finite dimensional vector space of dimension n, then as in the case of Fn, space of n tuples, where each element basically is of the form of coordinate type of things, alpha belongs to the Fn, alpha is having components like x1, x2, xn type. This is a coordinate structure, we see it. His first entry is x1, second x2, like that. So, similar coordinate concept can be also introduced by considering order basis for any finite dimensional vector space. And on the basis of that, we defined for a given order basis in a given finite dimensional vector space for an element alpha, a coordinate matrix with respect to that order basis, please. And we have seen that there is a one-to-one relation between the set of elements of V, that finite dimensional vector space V, say dimension n over the field say capital F, to our corresponding vector space Fn. And in terms of coordinate matrix also, one can say similar relations, that for each element alpha belongs to capital V, one can have a column matrix over Fn cross 1, please. Similar to Fn, Fn cross 1, I mean collection of all the column matrix, n cross 1 column matrix, they also form a vector space over A, please. You can check it easily. So, there is a one-to-one relations also. To raise one questions, if you recall correctly, let capital V be a finite dimensional vector space over capital F, field capital F, and dimension say n. Let B equal to alpha 1, alpha 2, alpha n, and B prime equal to alpha 1 prime, alpha 2 prime, alpha n prime be two order basis of capital V. Let alpha be any element of capital V with coordinate matrix of alpha with respect to B and with respect to order basis B primes be capital X and X prime respectively. Here capital X equal to say x1, x2, xn transpose, and capital X prime equal to x1 prime, x2 prime and xn prime transpose. Now, we are curious to know, is there any correlation between capital X and capital X prime? So, question is, does there exist any relation, any correlation between capital X and X prime? Answer is yes. My claim is that there exists an n cross n invertible matrix capital P over the field capital F such that capital X equal to P into X prime, or coordinate matrix of alpha with respect to B equal to P into coordinate matrix of alpha with respect to B prime. So, now the question is how? Given that B and B primes are order basis of B. So, this implies for each element of B prime I will be able to express in terms of linear combination of the elements of B. So, I can say for each alpha j prime belongs to B prime, there exist n scalars, say P I j I equal to 1 to n, such that your alpha j prime equal to sigma P I j and alpha I equal to 1 to n. So, I have written alpha j prime equal to linear combination of the vectors of alpha I, please. Already I have mentioned that the scalar product star, though there is no binary operation I have not mentioned, but there is a binary operation between P I j and alpha I, that is the scalar multiplication over the vector space V, please. According to given information, given condition, your alpha equal to sigma xi alpha I, sigma xi alpha I equal to 1 to n, and also alpha equal to sigma xj prime alpha j prime j equal to 1 to n, because it is given to me that coordinate matrix of alpha with respect to order basis B is equal to capital X and with respect to B prime is equal to X prime. So, I can write down like this star and double star on page. So, this implies I can write down alpha which is equal to sigma xj prime and alpha j prime j equal to 1 to n. But if you recall that we have already written that, so I can give this equation 1, each alpha j prime can be also written as a linear combination of alpha I. So, this means that I can write down this is equal to as sigma xj prime and sigma Pij and alpha I equal to 1 to n, and here j is equal to 1 to n, please. Now, this is a finite sum, I can exchange the order. So, I can rewrite this sum as sigma I equal to 1 to n and j equal to 1 to n Pij and xj prime, this whole multiplied to the alpha I. So, what does it represent then? So, this implies that if I want to know the coordinate matrix of alpha with respect to order basis B, because I have written alpha as a linear combination of alpha I, this implies that sigma Pij xj prime is basically ith component of the coordinate matrix of alpha with respect to order basis B. So, I can say this is j equal to here 1 to n, this is nothing or simply xi. because I have to compare the coefficients of the alpha I both side. Because this side we have, if you see the star, the sigma xi alpha I, which is equal to, I have written sigma I equal to 1 to n and sigma j equal to 1 to n pij xj prime. So, I can simply say that xi equal to this for I equal to 1 to n. So, this implies I can say capital X equal to Px prime, because this is true for I equal to 1 to n. So, x1 equal to this, x2 is equal to again similar. So, if you write like this, you will have your capital X equal to P into x prime. So, this is the relation please. Now, claim P is invertible. Suppose not. Then we know if P is not an invertible matrix, then there exists x prime not equal to 0, but P x prime equal to 0. So, this implies alpha which is equal to sigma x j prime alpha j prime j equal to 1 to n. Here this will not equal to 0, but P x prime equal to 0 implies x equal to 0. So, x equal to 0 implies your alpha which is equal to sigma xi alpha I equal to 1 to n, that must be equal to 0. So, in one hand I am getting non-zero, another I am getting 0. So, this is not possible. So, that P is not invertible is not possible. So, P is invertible. We have seen is alpha j prime is equal to sigma P I j alpha I equal to 1 to n. This implies the coordinate matrix of alpha j prime, it will be equal to your P1j, P2j and like Pnj transpose. So, this is basically I can write down the jth column of P matrix. So, this is with respect to B please, yeah. So, let me conclude it. Let V be a finite dimensional vector space of dimension n over capital F. Let B and B prime be two order bases of V, then for each alpha belongs to V, there exists a unique invertible n cross n matrix over over capital F such that coordinate matrix of alpha with respect to order basis B equal to P times coordinate matrix of alpha with respect to B prime, and coordinate matrix of alpha B prime is equal to P inverse coordinate matrix of alpha with respect to B. So, this is the basically conclusion of this result please. So, let me take some example please. Okay. Before taking examples, now the next question is like this. Now, suppose V is a finite dimensional vector space over the field say capital F and B be a order basis for V, this is given to us. Now, suppose a n cross n invertible matrix P is also given to us, then does there exist an order basis B prime such that coordinate matrix of any vector alpha with respect to order basis B will be equal to P times coordinate matrix of alpha with respect to that order basis B prime, say? That is the question, please. Answer is again yes, one can have a second order basis if an invertible n cross n matrix is given to us, which is of course it has to be defined over the corresponding field, please. So, let me take an example first. Let V is equal to F3, I mean space of 3 tuples over the field capital F. For sake of simplicity, I can take F equal to real number. Let B a order basis, this is E1, E2, E3, where E1 equal to, I can say that 1 0 0 and E2 is equal to 0 1 0, E3 is equal to 0 0 1. So, I have taken standard basis for the F3. Okay. Since I am saying that the first element is E1, second E2, third E3, I am also saying this in order basis. So, this be an order basis. Let B prime, I am considering another order basis. Okay. So, I am saying that, say, I have given the name as E1 prime, which is equal to 1 1 1, E2 prime, which is equal to 1 1 0, E3 prime, which is equal to 1 0 0. One can immediately check this B prime is a basis for the space F3 also, because if you see in the linear combination of C1 E1 prime plus C2 E2 prime plus C2 E3 prime equal to 0, if you consider for any C1 C2 C3, you will see that C1 equal to 0, C2 equal to 0 and C3 equal to 0 is the only solutions. And that can be also trivially obtained because the coefficient matrix will be invertible matrix, please, we can check it. So, this is given to us, B prime is also an order basis. Let alpha equal to x, y, z be any element in V which is equal to F3, please. So, this one please. So, what about the coordinate matrix of alpha with respect to B? Then the coordinate matrix of alpha with respect to B will be equal to C1, C2, C3 transpose, where x, y, z equal to C1, E1 plus C2, E2 plus C3, E3. So, if I simplify these ones, this is basically nothing C1, C2 and C3 you can, because E1 equal to 1 0 0, E2 is equal to 0 1 0, E3 equal to 0 0 1. So, if we simplify, then I am getting this C1 E1 plus C2 E2 plus C3 E3 equal to the C1 C2 C3. This implies the coordinate matrix of alpha with respect to standard order basis will be your x, y, z transpose. This is one. What can you say about the coordinate matrix of alpha with respect to B prime? Okay. So, I do not know, let me quickly calculate it. So, I know x, y, z equal to, I can say C1 E1 prime plus C2 into E2 prime plus C3 into E3 prime, please. This is equal to C1 into E1 prime means 1 1 1 plus C2 into 1 1 0 plus C3 into 1 0 0. This is equal to C1 plus C2 plus C3, C1 plus C2, this is second entry, and third entry will be your simply C1, because I have to calculate, I have to find out what is C1, C2, C3. Once this is known, then the transpose of this coordinate matrix will basically give me the coordinate matrix of alpha with respect to order basis B prime. So, comparing this, I am getting the equation. So, C1 equal to Z and C1 plus C2 equal to Y. This implies that your C2 is equal to Y minus Z, and C1 plus C2 plus C3 equal to X implies that C3 is equal to X minus Y. So, this implies coordinate matrix of alpha with respect to order basis B prime will be what? C1, that is Z, C2, that is Y minus Z, C3, that is equal to X minus Y. Okay. So, by definition of the coordinate matrix of a vector, I have the coordinate matrix of the vector alpha with respect to both the order basis I have already derived. Now, we want to check whether by that relation that there exists a non-singular matrix P such that capital X equal to P into X prime. Let us see it. So, my X prime is equal to here what? Z, Y minus Z, X minus Y, and capital X equal to what? This is equal to X, Y and Z. Okay, it's fine. Now, I have to find out the P matrix. According to definition of the P matrix, we know the first column P1 of P matrix is basically coordinate matrix of E1 prime, I can say this one, with respect to order basis B. That will be my first column of P, and second column of P2 of P will be coordinate matrix of E2 prime, and similarly P3 E3 prime. This is equal to how much? See, E1 prime means 1 1 1. So, if I write down, this implies 1 1 1 equal to C1 E1 plus C2 into E2 plus C3 into E3. So, this implies if E1 I know 1 0 0, E2 0 1 0, E3 0 0 1. So, the coordinate matrix of E1 prime with respect to B is equal to, it will basically 1 1 1, this one. C1 will be 1, C2 will be 1, C3 will be 1. And what about the P2? P2 will basically, I have to write down E2 prime. So, if I write E2 primes with respect to order basis B, it will be again, I will have 1 1 0, and E3 prime I will have with respect to order basis B is equal to 1 0 0. So, this implies my P matrix is equal to 1 1 1 1 1 0 1 0 0. So, this is an invertible matrix which can quickly check it. Now, I want to cross check whether my X is equal to P into X prime or not. Now, if I see the P into X prime, this is equal to how much? This is equal to 1 1 1 1 1 0 1 0 0 times Z Y minus Z and X minus Y. Okay, so there may be some error, I do not know, but you have to cross check please. Simply do not trust on my this algebra please, you have to also cross check and see what I have written correct. Okay, let me see it. So, this is basically z plus y minus z and plus x minus y. So, this is equal to your x, z plus y minus z which is equal to y, z. So, this. Okay. So, I am getting basically like this. This implies that I am getting this is equal to, I can write down, yeah, this is equal to capital X. So, P x prime equal to x, please. Now, suppose P is given where P is invertible and over the given field. How to find the second order basis when one order basis is given in this space, please. And it is also given B is equal to say alpha 1, alpha 2, alpha n, an order basis of B. Okay. Then there exists a unique order basis B prime consisting of alpha 1 prime, alpha 2 prime and alpha n prime, such that for any alpha belongs to B, the coordinate matrix of alpha with respect to B is equal to P times coordinate matrix of alpha with respect to B primes, or P inverse coordinate matrix of alpha B equal to coordinate matrix of alpha B prime. Now, how to prove that one also? This proof is again a not difficult one. So, the proof is like this. Let Q equal to P inverse, because P is given to me invertible. So, I can write Q equal to P inverse, please. Okay. So, like this thing. We know alpha j prime, I mean we can construct vectors alpha j prime equal to as sigma p I j I equal to 1 to n and alpha I. So, j equal to 1 to n. So, I can have alpha 1 prime, alpha 2 prime, alpha n plus this thing. Let B prime equal to alpha 1 prime, alpha 2 prime and alpha n prime. So, I have constructed n elements of capital V, please. I claim this is a order basis for the vector space V, please. With this order, first element is my alpha 1 prime, second is alpha 2 prime and nth is alpha n prime, please. Okay. If I somehow can show that this n elements span your vector space V, then I am through, because the dimension of the vector space V is n. So, we need for any basis exactly n number of linearly independent elements. There are exactly n elements. Now, if I show that they span the space V, then I am through. So, what I will do, consider a linear combinations like sigma q j k and alpha j equal to 1 to n, okay, alpha j prime, please. If somehow I can show that these linear combinations give me an element from B, then also I am through. Okay. Now, this sigma q j k alpha j prime, this is j equal to 1 to n equal to, I can write down sigma j equal to 1 to n q j k, but alpha j prime is equal to sigma p I j. So, this is given to me. So, I can simply write down this one also, p I j and alpha I equal to 1 to n. So, this is equal to, I can write down sigma I equal to 1 to n, sigma j equal to 1 to n p I j and q j k this alpha I. Now, this implies the sigma q j k alpha j prime j equal to 1 to n, this is equal to Q is inverse matrix of P. So, if I consider P and P inverse, then it will be only first row multiplied with first column will have only first entry equal to 1, all other 0. Similarly, second row multiplied to the first one, it will basically give me 0. Since P into P inverse is equal to, we know, identity matrix, this is 1 0 0 like this, 1 0. So, definitely it has to follow like this. So, this implies that I can write down this is equal to simply I equal to 1 to n delta I k type and alpha I. Delta I k means equal to 1 for I equal to k 0, I not equal to k. So, this means that this is going to be give me simply alpha k. So, linear combinations of alpha j prime give me alpha k also. I mean linear combination of alpha j prime with coefficient as q j 1 j equal to 1 to n. So, this implies one can obtain alpha 1, alpha 2, alpha n as a linear combination of alpha 1 prime to alpha n prime. So, this implies B prime consisting of alpha 1 prime to alpha n prime span vector space V. So, what we have learned today? We have learned that if we consider two different order bases for a finite dimensional vector space, then the coordinate matrices of any vector alpha are related by some non-singular invertible matrix P such that coordinate matrix of alpha with respect to B equal to P times coordinate matrix of alpha with respect to second basis place. And an invertible matrix is given which is defined over the same field, basically on which vector space is defined, then also when one order basis is given, one can have another order basis place. Thank you.